Welcome back. In this video we're going to explore the derivative of the natural log function. Remember, the natural log function is the ln of x, and with this x, technically the ln of the absolute value of x, because this can never be a negative value because the ln of x has a vertical asymptote on the y-axis. So when I take the derivative of this, sometimes the absolute value is written, sometimes it's not. I'm not going to beat you up about that. Take the derivative of the ln of x, I get 1 over x. If I put a function there, I take the derivative of the ln of u, I get 1 over u, and then times du dx. That's that little bit of chain rule. Lots of examples. Sometimes you have to simplify this stuff. So in the first one I have y equals the ln of 2x plus 3, and I want to find the derivative. So it's going to be y prime is going to be 1 over 2x plus 3, and then times 2 because that little chain rule. We would obviously write that as 2 over 2x plus 3. Sometimes you get some problems in which you have to simplify the log expression. So like when I have this y equals the ln of the square root of x squared minus x plus 1, I can write that this way. And then I can pull that 1/2 right there because the property of logs out front. So before I even take the derivative, I can write this as 1/2 ln of x squared minus x plus 1. And then taking the derivative is a lot easier because y prime, that 1/2 is a constant, and then it's going to be times 1 over x squared minus x plus 1, and then finally times 2x minus 1 because of the derivative of the denominator. You probably would see the answer more like this. It would be probably 2x minus 1 over 2 times x squared minus x plus 1. It's really helpful to simplify your logs. Anytime you can apply those properties, simplify your logs. We also can't forget about our chain rule and our product rule and all that stuff. So in this particular one, again, I'm going to simplify this. It's x times the ln of the square root of x. But again, just like I was showing you, because of that square root of x, I can write that as x to the 1/2 and then pull the 1/2 out front. So before I even take the derivative, I'm going to write this as 1/2 times x ln of x. It's 100 times easier to take the derivative of that when you have it in that format. I have to use a little bit of product rule because the x ln of x, I can pull the 1/2 out front. So y prime is 1/2, and then it's going to be ln of x plus x times 1 over x. This is obviously just going to be 1, so it's going to be 1/2 times ln of x plus 1. And in this particular example, I asked you to solve it for 0. So I'm going to set that equal to 0. The 1/2 will just divide out. So really, I get the ln of x plus 1 equals 0, or the ln of x equals -1. And then you do have to rewrite that as an exponential. So x equals e to the -1, or 1 over e. We're going to get more into those properties of logs and exponentials as we go through the class. And then finally, my last one, remember another property of logs is if I have division problems, I can write them as subtraction, or if I have multiplication problems, I can write them as addition. So I can rewrite this as y equals the ln of 2x plus 1 minus the ln of 1 minus x, and now take the derivative of that. And it's a lot easier to take the derivative of this equation. So y prime would be 1 over 2x plus 1 times 2 minus 1 over 1 minus x times -1. Times -1 because that derivative of 1 minus x. You know, I don't care if you write it this way or not. It's going to be 2 over 2x plus 1 plus 1 over 1 minus x. If you write that as a common denominator or not, it doesn't really matter unless I've asked you to solve it. All right, sorry about that, Bell. See you in class soon.